Look up at the sky tonight and find a star, any star. Now ask yourself an honest question. Could something living on a planet around that star reach it? Your gut says yes. Your gut is actually wrong. No, because aliens don't exist. No, because the universe is empty. Because the universe has 5 laws written into its reality, 5 absolute answers, 5 rules that have no appeal. And by the time we're done with this day, you'll understand exactly why the night sky is silent. Probably not silent, permanently, physically, mathematically silent. Let's get started. There's a question that's haunted every civilization that's ever looked up at the sky. Where is everyone? The ancient Greeks looked up at the stars and imagined gods living among them. Medieval scientists debated whether other worlds existed. And in 1950, Enrico Fermi, one of the greatest physicists who ever lived, sat down with his colleagues for lunch and asked them the most devastating question in the history of science. If intelligent life is common in the universe, where is it? He didn't ask it dramatically. He asked it like you'd ask why the bus hasn't arrived yet. Simple, logical, and completely unanswerable. We call it the Fermi Paradox, and for 70 years scientists have been trying to solve it. Some say civilizations destroy themselves before they reach us. Some say they hide. Some say we're not listening properly. But that's what almost no one tells you. The answer may have nothing to do with civilizations. The answer may be written into the laws of physics themselves, not as a puzzle to be solved, as a verdict to be made. There are 5 of these verdicts, and each one is more devastating than the last. We use the word space frequently in our daily life. Just like we say outer suburbs, we say outer space, as if it's a little further away, but it's not. Let me show you what distance really means out there. Let's start small. The Earth is about 12,700 kilometers wide. You could fly around it in less than 2 days. Now let's take a step forward. The Sun is 150 million kilometers away. Light, the fastest thing in the universe, takes 8 minutes to travel that distance. Even if the Sun were gone right now, you'd still feel its heat for another 8 minutes. That's a distance you can almost feel. Now, let's take another step forward. The nearest star, not a distant galaxy, not a speck of light on the horizon of the observable universe, just a next-door neighbor, Proxima Centauri, 4.24 light years away. That number sounds small. 4. You ate 4 slices of pizza. You waited 4 minutes for the bus. 4 seems manageable. No, it's not. Consider the fastest object humanity has ever built, the Parker Solar Probe. It travels through space at 692,000 kilometers per hour, fast enough to fly from New York to Tokyo in less than a minute. If you were to board that probe right now and aim it for Proxima Centauri, how long would the journey take? 6,600 years. Think about that for a moment. If someone had launched that probe the day the last stone of the Giza Pyramid was placed, they would now be reaching our nearest neighbor, the nearest star. Our home galaxy, the Milky Way, is 100,000 light years wide. At the speed of the Parker Solar Probe, it would take hundreds of millions of years to traverse it, longer than the entire history of mammals on Earth. You would have evolved into a different species before reaching halfway. That's the first, an unimaginable distance. But you might be thinking, so what? We need to go faster. That brings us to the second conclusion. Most people think of the speed of light in the same way they think of the sound barrier. We used to think that nothing could travel faster than sound. Then we built better engines and broke it. So with enough time and technology, we could break the light barrier. This is the most plausible sounding misconception in all of science. The speed of light is not an engineering problem. It is not a technical limit waiting for an intelligence. It is a structural limit of reality itself. It is the speed at which cause and effect operate. It is the maximum speed at which anything in the universe can affect anything else. Here is the simple version. In ordinary life, if you push something harder, it goes faster. If you push twice as hard, it goes twice as fast. It is obvious. This is how everything works on a human scale. But as you approach the speed of light, reality stops behaving. The energy you put into accelerating a ship stops making it faster and starts making it heavier. It's not literally heavier, like a bookcase is heavier. It's relatively heavier. The universe itself is retracting. It takes infinite energy to accelerate any object with mass to 100% of the speed of light. Not all the energy, not all the energy, infinite energy, energy that doesn't exist, energy that can't exist. Think about it. There's not enough energy in the entire observable universe to accelerate a single grain of sand to the speed of light. This is not a wall that we can break down. This is the universe telling us, clearest mathematical language, this door won't open. So when people ask aliens why they can't just get here faster, the answer is simple: because they can't. It doesn't matter how advanced they are, they live in the same universe as us. They obey the same Einstein as us. But let's say we accept the speed limit, let's say we're patient, we'll be traveling at 10% of the speed of light, slow by cosmic standard, incredibly fast by ours, which brings us to the third proposition. In 1903, a Russian school teacher named Konstantin Tsiolkovsky wrote a simple equation. It's the most brutal equation in the history of science. Here's what it says. In simple terms, you need fuel to move a ship, but fuel has weight, so you need more fuel to move the fuel that moves the ship, but that extra fuel also has weight, so you need more fuel to move the extra fuel, and so on and on. It's an exponential trap with no way out. Have you ever tried to fill a bathtub with a leak in the bottom? You pour water in, but the hole drains it faster than you can fill it. No matter how fast you pour it in, you can never win. That's the rocket equation, but the more water you add, the bigger the hole gets. Let's put it into concrete terms. Imagine you want to send a ship to Proxima Centauri and you want to get there in a human lifetime. For example, 40 years. You have to accelerate to a meaningful fraction of the speed of light, but here's the part that everyone forgets. When you get there, you have to stop. It takes as much fuel to stop as it takes to accelerate. That means you have to carry all the brake fuel with you along the way, accelerating the brake fuel the entire way. That takes more fuel to move that fuel. If you do the math using our best chemical rockets, the amount of fuel needed to send a single person to Proxima Centauri in a reasonable amount of time would exceed the mass of the entire observable universe. Every atom of matter we can detect, not enough. And what about nuclear fusion? We don't have it yet, but let's imagine we do. Even with fusion, the most efficient reaction we know of, the ship would have to be almost entirely fuel. We're talking about a flying fuel tank the size of a skyscraper carrying a payload the size of a refrigerator. And antimatter? The most powerful fuel source imaginable. A gram could destroy a city. But we produce antimatter atom by atom. All the energy produced by human civilization over millions of years would barely fill a handful. Even a civilization that harnesses all the energy of its star, what physicists call a Dyson sphere, would have to look at these numbers and do the math. Why waste the energy of a star visiting a small planet when you can use it to build something amazing in your own backyard? Advanced civilizations aren't just powerful, they're efficient, and interstellar travel is the opposite of efficient. But let's say they don't care. Let's say they have infinite energy and they're going to work anyway. Now they're facing the fourth law. We imagine ourselves in spacesuits floating gracefully among the stars. The image is beautiful, but the biology is not. The human body is designed for exactly one environment, Earth, 1 gram of gravity, atmospheric pressure, the protection of the magnetic field. If you take any of these away, the body begins to fail. Space is a radioactive wasteland. Outside the Earth's magnetic shield, cosmic rays penetrate everything. They are not rays of light. They are subatomic bullets, protons, and heavy ions traveling at close to speed of light. They pass through metal wall. They pass through your body. They find the molecules of your DNA and break them apart like a hammer breaks glass. Your risk of cancer increases significantly on a 6-month trip to Mars. On a trip to another star, even at 10% of the speed of light, taking 40 years, the radiation dose would be many times more lethal. You need shielding, thick shielding, meters of lead, water, or rock. But shielding is heavy, and weight means more fuel, and more fuel means the rocket equation is getting worse again. It's a dead end. And radiation is just one problem. In zero gravity, bones lose about 1% of their density per month. Muscles weaken. The heart shrinks because it no longer has to work as hard to pump blood upward. Vision changes as the fluid pressure inside the skull changes. After 6 months on the International Space Station, astronauts return unable to walk. Imagine a 600-year journey. You might be thinking, freeze them for the journey. Here's the problem. When water freezes inside a living cell, it forms crystals. The crystals have sharp edges. These edges tear through the cell membrane from the inside like a knife through paper. We don't know how to freeze a person and turn them back into a living. Every attempt creates a broken collection of destroyed cells, not a sleeping passenger. Then the generation ships. Let them live on the ship and die. Their grandchildren will come. Put 500 people in a metal cylinder for 500 years. Watch what happens to their social structure, their languages, their gene pool. History shows that they will not come as explorers. They will come as something none of us could have predicted. Biology is the software of Earth. It does not work in the hardware of space. But maybe the travelers are not biological at all. Maybe they are sending machines. Silicon does not get cancer. True. But silicon is also sensitive to radiation. Cosmic rays turn particles in computer memory, corrupting data for years, then decades, then centuries. Metal fatigue, micrometeoroids, dust grains traveling at a significant fraction of the speed of light strike the hull with the force of hand grenade. In deep space, even the most robust machine falls silent over thousands. Even a machine faces a fifth and final judgment. Let's say a civilization has figured it all out. Distance, energy, biology. They're there. They exist. They're capable. Why haven't they called? Because the universe is a terrible phone service. We've been broadcasting radio signals for about 100 years. That means our existence has created a bubble on Earth 100 light years wide. In a galaxy 100,000 light years wide, our bubble is invisible. A single grain of sand on a beach stretches from here to the moon. We scream, but we're screaming into a hurricane. For a civilization to detect us, they have to point their instruments at our star at exactly the right frequency, at exactly the right moment in cosmic time. Think about asynchronous civilization. Humanity has been technologically capable for maybe 200 years. We might live another 1,000 years, maybe 10,000 years if we're lucky. But the universe is 13.8 billion years old. The chances of two civilizations existing at the same time, in the same neighborhood, at comparable technological levels are extremely slim. It's like two fireflies blinking in a forest the size of a continent, one on a Tuesday evening 1 billion years ago, the other on a Thursday 1 billion years later. They never see. A civilization may have flourished near Proxima Centauri 1 billion years before our sun formed. They're gone now. Another one may arise there 1 billion years after. The tragedy of space is not that it's empty, it's that the visitors arrive at different times. This is what I want to tell you. The same rules that trap us here are the same rules that make us possible. If the speed of light were not a constraint, causality itself would break down. Effects could happen before cause. A universe without this rule would be a universe where history could not exist, where nothing is remembered, where nothing is built. The rocket equation exists because energy is conserved, and the conservation of energy is what allows stars to burn steadily for billions of years, long enough for planets to form, long enough for oceans to fill, long enough for something like us to emerge and ask these questions. The biology that breaks down in space is the same biology that consciousness evolved from. The same fragility that makes us vulnerable to cosmic rays, the fragility of a nervous system complex enough to think about its own existence. Silence doesn't mean we're abandoned, it means we're rare, and there's something to that. We're the result of 13.8 billion years of cosmic process, stars that burn and explode, galaxies forming and colliding. Chemistry becoming more complex over billions of years. Finally, in a tiny corner of one remarkable galaxy, matter transformed itself to something that could understand the universe that created it. We may never shake hands with another mind among the stars, but we share the same physics. We share the same element. The carbon in your body and the carbon in any life that may exist elsewhere formed in the same kind of dying star. We are connected not by ships or signals, but by the laws of nature itself. So when you look up at the night sky and feel the silence overwhelm you, don't feel forgotten. Feel what you really are by looking into the universe, into itself. That's enough for now.